Okay, let us take another example that this was easy example because there is no x. But if you take x there, how would that look like? Let us do that problem. Okay, let's take that. Let us see this example. So first of all, let us write down what is a, what is b, what is fx, right, like that. Okay, what is fx? Fx is this function 2x squared plus 5. What is a? A is negative 2. What is b? B is positive 1. So this implies that what is delta xi then? Delta xi will become b minus a over n. What is that? 1 minus negative 2 divided by n. That is 3 over n. We got 3 over n again, but you may get different number in the different problem. You don't have to get 3 over n all the time, okay? So what is ci also? Ci, the formula for ci is a plus I times delta x, right? So what is a? A is negative 2 plus I is 3, I is I, right? I is I, and then delta x is 3 over n. Basically, you can write negative 2 plus 3I over n, that is ci, okay? So what is f of ci then? F of ci will become, you write, just replace x by ci there, right? So it is 2ci square, right? And then plus 5. But what is ci though? Ci is negative 2 plus 3i over n. So it will be 2 times negative 2 plus 3i over n square plus 5. This is a ci square, right? Now let us simplify that. What do you get? So 2 times, you can just FOIL this, right? Negative 2 plus 3i over n, and then times negative 2 plus 3i over n. You see that? And then plus 5 is there. Now you will FOIL that. How do you FOIL? You multiply this with that, right? So you multiply this negative 2 with negative 2, and then negative 2 with 3i, and then 3i over n times negative 2, and like that, right? That's how we FOIL. So what do you get? That's basically, let me keep that 2 outside. So what do you get? Negative 2 times negative 2 is positive 4, right? Negative 2 times negative 3i over n. What do you get? Is negative 6i over n. Now you multiply with 3i over n times negative 2 is negative 6i over n, right? And then plus 3i over n times 3i over n will be 9i square over n. This is what I get. Plus 5. Let me simplify this. What do I get? So let me write 2, and then 4 minus 6i over n minus 6i over n will be 12i over n, and then plus 9i square over n, and then plus 5 is still there. So if you simplify, the final simplified form will be 2 times 4 is 8 minus 24i over n, and then plus 18i square over n plus 5, right? If you further simplify this, basically you will get 5 plus 8 is 13, right? Minus 24i over n, and then plus 18i square over n. This is what you get, okay? Let me write this way, okay? Now what do you get then? So let me write down in the formula form, okay? So negative 2 to 1 2x squared plus 5 dx. This is basically the definite integral equals to limit, right? The norm tends to 0, summation I runs from 1 through n, f of ci times delta xi. This is the formula, right? So which is equals to, this can be written as limit n tends to infinity as previous, right? And then summation is still there, I runs from 1 through n. What is f of ci? Just copy that term. So 13 minus 24i over n plus 18i square over n, and then times, what is delta xi? Delta xi is 3 over n, right? That's what the delta xi is. So the times 3 over n. Let me multiply this everything. Let me FOIL with the 3 over n. Let me distribute this 3 over n to everybody there. So limit n tends to infinity, summation I runs from 1 through n, right? So 13 times 3 is how much? 39 over n, right, minus 72i over n square, right, and then plus 18 times 3 is 54i square over n square again. You see that? Oh, by the way, I forgot n square here. This should be n square, n square, n square, n square. So this should be n square too, and this should be n to the cubed. Why? Because n square times n. So 18 times 3 is 54 I square divided by n to the cubed. Now what we do is you distribute this summation to everybody there. So you will get equals to limit n tends to infinity, right? And then what I'm doing is I'm giving this summation to everybody. So summation I runs from 1 through n, 39 over n, okay, minus. So let me write down another term. Summation I runs from 1 through n, 72i over n square, and then plus summation I runs from 1 through n, 54i square over n to the cubed. You see that? So this is what you will get. Next, what we do is, since here is no I, you can pull that out. So summation of the constant will be n times that, right? So let me write that limit n tends to infinity. The first sum is 39 over n times the n. You see that? Because the summation of c is c times n. So you are adding that n times. There is no I, so you don't have to do, you don't have to use any formula for that. Just n times that, right? Now minus, you pull that 72 over n square out. What is left is summation I. What is the formula for summation I? It is n times n plus 1 over 2. You see that? That's the summation of I there. And then plus, what do you get there? 54 over n cube is outside. And what is the formula for summation I square? It is n times, so n plus 1 and then 2n plus 1 over, this is what you get. Okay, now let us simplify this. What do you get? So basically, this is n and n cancel out. So this is 39. You don't need a limit for that 39, right? I mean, you can keep. It doesn't hurt. But let me keep. Limit n tends to infinity. 39 minus. What do you get here? You can cancel n and n, right? Or you can, what you can do here is divide that 72 by, divide the 72 by 2. That will be 36, right? So you can write 36, right? And what do you get there? N times n plus 1 is n square. Let me use the same color, okay, guys? So this is 36 times n square plus n. I'm distributing that. Divide by n square, right? You see that? I'm just giving that n square here. So it is fine because there is a product. And then plus, what is 54 divided by 6? 54 divided by 6 is 9, right? So what you get next is, you can write 9 and then just write down n times n plus 1 times 2n plus 1 over n to the cubed. You can, the easiest way would be, you can just FOIL that, okay? But you don't have to. If you FOIL that, it will be easier for you guys. But you don't have to. So we will use some just factoring out technique, okay? So let us split the denominator here. What do you get? If you split that, you will get, let me write down limit n tends to infinity, right? There is 39 minus 36 times, it is n square over n square plus n over n square, right? Did you see that? And then plus 9 times, if you divide that, this one n and then another n, one of the n will cancel out. So what is left is n square, it will be left, right? So what I want to do here is, I want to factor out n from this parenthesis and factor out n from the another parenthesis. So this is what I'm going to get, okay? So I will get n 1 plus 1 over n, right? And then another n, taking out 2 plus 1 over n, okay, over n square. Why do I do that? Is I want to cancel that n and n square there, okay? And then I will take the limit here. So n, and then n is n square, so that will cancel out with that n square. Also, this will cancel out, this will cancel out with one of those, okay? So what is happening there then? So let me close that parenthesis because there is limit outside. So let me write on, after that I want to write down here, okay? So this is equals to limit n tends to infinity, okay? So what is left is there is 39 minus 36 times 1 plus 1 over n, okay? And then plus 9 times 1 plus 1 over n times 2 plus 1 over n, because all the other things are cancelling out. Now what we do is I'll plug in the limit. If you plug in the limit, what happens there? This will become 0 because n tends to infinity. You are dividing 1 by infinity. That will be 0, this will be 0, and that will be 0. What do you get? Is you get 39 minus 36, right? And then times 1 is 36 plus 9 times 1 times 2 is 18, right? So basically you will get this one. So the final number you will get is 39 minus 36 plus 18, right? Because 9 times 1, because this will be 0, that will be 0. So 2 times 1 times 9 is 18. So what do you get? 39 minus 36 is 3 plus 18 is 21. So this is the final answer, okay? So you will see this type of problem in your homework too. So that will be the end of this video. Thank you guys.